All right, so we're going to keep going over this here. Finish up this solving, kind of going over the formula in this here. Now we finished up with this in the last one on Friday, 5i. And we got the two solutions, multiplied them together and realized that we got negative 5i. And part of that's coming from the fact, really dealing with the square root of I squared. And it's tempting to say that it's equal to negative 1, but it's not. And it's all dealing with the properties of I squared, and that's really the issue, because it's really when we take the square root of I squared, we get just back to I. And we have this sign error that can show up, especially with even roots. So we got the correct roots, that was the correct answer, but when multiplying even roots of these complex numbers, we're going to have a sign error. I did do some checking with it, and especially our odd roots, they actually work out that we can multiply them together and get back to the exact answer. But it seems like the ones I tried, because I did try another one with even roots, and it worked out that the answers that we got were the same numbers but different signs, like the signs got flipped. And I'm a feeling it's because of that sign error that occurs with our square root of I squared, that negative. But we're going to look at this one here, and we're trying to find the square root of 2 plus 2i. Now our formula, z sub k, is equal to the nth root of r times cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. And this is just our formula for this here. So what we need for this here is one, the value of r, theta, n, and k. Well, n was given to us because we're finding the square root. So n is 2. Values of k. So we start with 0 and go up to n minus 1. So we start with 0 and then 1, because our 2 minus 1 would be 1. So we just have these two roots. Now the two things we need to find, one is r. R is equal to the square root of a squared plus b squared. Well, our a value in this case is 2. Our b value in this case is also 2. Did we do this one? Okay. Now our square root of, well, our 2 squared plus 2 squared gives us the square root of 8. So we have to leave this alone as the square root of 8. And normally we would put this in the calculator and get 2 square roots of 2. But we have a little bit of an issue with the fact that we're going to have to take the nth root of it. Okay, that must be square root of 8. Now, to find theta, theta is equal to tangent inverse of b over a. For us here, this would be tangent inverse of 2 over 2. And if we plug this into the calculator, it's going to tell us that this is pi over 4. So we get this here. Questions on r, theta, and n and k. So when we set this up, we're going to set it up as two of them. We'll have z sub 0 and z sub 1. I'm going to go on and set them up fully, and then we'll do calculations in a minute. Now, z sub 0 is going to be the square root, so 2 is our n, of r, so the square root of the square root of 8, times cosine of our theta, which is pi over 4, plus 2 pi times 0 over 2. So we're filling in pi over 4 is theta, and our k values for this first one are all going to be 0, plus I sine of pi over 4 plus 2 pi times 0 over 2. So this here is our z sub 0. Now there's a few things we can calculate out first. One of them is going to be the square root of the square root of 8. And instead of doing this multiple times and rewriting it out, I'm going to do this kind of off to the side. We have the square root of the square root of 8. Now to simplify this, we need to go back to our properties of radicals. The nth root of a to the x is equal to a to the x over n. Now for us here, this first radical, well, 2, 1 is just saying that we have the square root of 8 to the 1/2 power. Well, it's also telling us 8 is also to the 1/2 power. And powers of powers multiply together, telling us we actually have 8 to the 1/4, which is the 4th root of 8. And if you ever have to do these here and have questions on making sure or trying to figure out if you got the correct one, the calculator will help us there. Because we could say the square root of the square root of 8 is this decimal here. We can also plug in the 4th root of 8. Let's see, we get the exact same thing. So the reason that's helpful is because now we can say what's out in front of the radical, or our sets of parentheses, is the 4th root of 8. So our square root of square root of 8 is the 4th root of 8 times cosine of, well, we can plug that in. I'm going to grab 30xs, fraction, pi over 4, plus 2 pi times 0 all over 2. We get pi over 8. Now it seems odd why I would type all that in, but it'll make sense here in a minute. And luckily what we get for cosines, angle value, sines will be the same because it's the exact same expression. Questions on this here so far? Now we're also going to do this with z sub 1. Now the r value, our nth root of r, that we have for z sub 0 is going to be the same for the rest of them. No matter how many we have, that radical is going to be the same. So once we find it for the first one, we don't have to re-find it for every previous or every following one. Not previous, every one that follows, we can just go on and write it down. Times cosine of pi over 4 plus 2 pi times 1 over 2 plus I sine of pi over 4 plus 2 pi times 1 over 2. And between z sub 0 and z sub 1, the only thing that's really changed is that now instead of having 2 pi times 0, we have 2 pi times 1. And this is this is the main reason I still put in 2 pi times 0. Is because I can copy it down, change it from 0 to 1, hit enter, and now I have 9 pi over 8. I only have to type it in once. And we have both of our expressions. Questions on this so far? Now the last thing we can do is actually figure out or calculate this out. So it is in radians, so we can say the 4th root of 8 cosine of, do not want that, pi over 8. Delete. We'll go out 4 decimal places for these here because if it doesn't give us a nice number, we're going 4 out. So 1.5538. Then we do the same thing for sine. Pi over 8. 0.6436. And we can't forget the I. Then we do the same thing for z sub 1. 4th root of 8 cosine of 9 pi over 8 negative 1.5538. Most likely the next one's also going to be negative, and it should be a number we've seen already. Negative 0.64356 pi. And these are the two solutions here. Now, even if you end up getting some numbers that are a little bit off, I will always go back and check these. So do make sure to have your z sub 0 all the way up to it in angular form, these here polar form. I will check those just to make sure you got the correct ones, just in case for some reason the calculator gave you something a little different, or if for some reason, easy to do, you type it in as the calculator is radians, but the calculator is set up in degrees, and it gives you completely different answers. But questions on this here. Find all 6 roots of 1. Well, n is 6. K is 0 all the way to n minus 1. So that means we'll have 0, 1, 2, 3, 4, 5. We're going to do this 6 times. Now we still need r and theta. R is equal to the square root of a squared plus b squared. Well, our a value in this case is 1, b is 0, which is really just the square root of 1 squared, which is just 1. So r is 1. Theta is equal to tangent inverse of b over a, 0 over 1. I believe this is 0 degrees. 0 degrees. 0 degrees or 0 radians. We'll do 0 radians because that's what we've been doing so far. Z sub 0 is equal to the nth root of r. So in our case, it's the 6th root of 1 times cosine of theta plus 2 pi times k, which is 0 over n, plus I sine of theta plus 2 pi times 0 over 6. Well, for us, the 6th root of 1 is 1 times cosine of, well, fraction 0 plus 2 pi times 0 over 6 is, surprise, surprise, oh, gosh, I need to be careful with that. I need to break that. Is 0. Or really, we can just say z sub 0 is cosine of 0 plus I sine of 0. Okay. And we'll come back to their values in a minute. Next, we can look at is z sub 1. Well, the nth root of r, our 6th root of 1 was just 1, times cosine of 0 plus 2 pi times 1 over 6 plus I sine of 0 plus 2 pi times 1 over 6. Well, the multiplication of 1 doesn't even matter. Now we just need to calculate this here and just replacing 0 with 1, pi over 3. So it tells us we have cosine of pi over 3 plus I sine of pi over 3. Yes? And again, we'll calculate all these values at the very end. Well, z sub 2, the only thing that's changing from the previous one is that instead of having 1, it's going to be 2. And the multiplication one's going to simplify, so we'd have cosine of this here with 2 plugged in. So I come up here and type in 2 and get 2 pi over 3. So we'd have cosine of 2 pi over 3 plus I sine of 2 pi over 3. Z sub 3. We're back over here. Plug in 3. Give us pi. So we'd have cosine of pi plus I sine of pi. Do the same thing for z sub 4. Four pi over 3. And lastly, we'll do this with 5 and get 5 pi over 3. So cosine of 5 pi over 3 plus I sine of 5 pi over 3. So these here, remove that. Are all 6 of the roots for this here. Now, what we can do at this point is type these in and see what we actually get. Cosine of 0 radians is 1. Sine of 0 radians is 0. So for our first root, our first answer, we get 1. Plus 0i, or we can just say 1. Pi over 3. Cosine of pi over 3 is 1/2. Sine pi over 3 is square root 3 over 2. So we'd have 1/2 plus square root 3 over 2 I. Same thing with 2 pi over 3. Cosine of 2 pi over 3, negative 1/2, sine of 2 pi over 3. We get negative 1/2 plus square root 3 over 2i. Do this next with cosine of pi and get 0. Or sorry, negative 1. Sine of pi is 0. So the next one would be negative 1. 4 pi over 3. Cosine of 4 pi over 3, negative 1/2. Sine 4 pi over 3, negative square root 3 over 2. And the last one's going to be positive 1/2 negative square root 3 over 2. Cosine of 5 pi over 3, positive 1/2. Sine of 5 pi over 3, negative square root 3 over 2. And those are all 6 roots. And they're always going to come this way because they need to come in our conjugate pairs. These here. But that's it. Questions on this here? Questions on how this theorem works? You feel comfortable with finding these roots? Okay. Now this one here is even easier because they already gave us r and theta in the formula. If we do need to look back at it, we can. Yeah, and this is the last one here. Might as well look at this one here. Whenever we solve these here, the first thing we need to do in solving them is to get whatever variable we have, because there's only going to be one by itself. So what we can do here is add our 1 minus I term to both sides, because here they would cancel. We could distribute the -1, but it would give us the same thing. And that x cubed is equal to 1 minus I. And to find the solutions, to find the roots, we're really at this point taking the cubed root. We're wanting to know what the cubed root of 1 minus I is. Now to do that, we're going to use our theorem. N in our case is 3. K is going to be 0, 1, and 2. We still need to find theta and r, because it's not in the correct form, the form we need. Well, r is going to be the square root of our a squared plus b squared. A in our case is 1. B in our case is -1. Well, our 1 squared is 1, -1 squared is also 1, and 1 plus 1 gives us 2. So we're told that r is the square root of 2, and we'll have to rationalize that out here in a minute when we take the cubed root of it. Theta is our tangent inverse of b over a, -1 over 1. In the calculator, we can say second tangent inverse of -1 over 1 is this here, or negative pi over 4. And that's fine and all, because negative pi over 4 is down here in the fourth quadrant. If we look at the term 1, -1, if we graphed it, 1, -1 would indeed be down here in the fourth quadrant. So they do line up, but we do need this to be between 0 and 2 pi when we start, because it makes things a little bit easier, a little bit nicer. So to get that, we're going to add 2 pi to it, and we'll get 7 pi over 4. Because here we can just add 2 pi, 7 pi over 4. So that's our starting angle. And now we can set the first one up. Z sub 0 is equal to the nth root of r. So it's going to be the cubed root of square root of 2 times cosine of 7 pi over 4 plus 2 pi times 0 over 3 plus I sine 7 pi over 4 plus 2 pi times 0 over 3. Now the cubed root of the square root of 2, I'm going to do this off to the side. Just as we had previously, the cubed root we can say is the 1/3 power. The square root is the 1/2. Powers of powers multiply, so we'd have 2 to the 1/6, which is the 6th root of 2. So for z sub 0, we have 6 root of 2 times cosine of, we can type this second part into the calculator, 7 pi over 4 plus 2 pi times 0 over 3 is 7 pi over 12. Z sub 1. It's still going to be the 6th root of 2. But as we've seen on the last few, the only thing that's changing from one to the next is that it's not going to be 0 inside our angle anymore. It's going to be 1. So there's not a whole lot of reason, unless we want to rewrite it out as the 6th root of 2 times cosine of 7 pi over 4 plus 2 pi times 1 over 3 plus I sine 7 pi over 4 plus 2 pi times 1 over 3. As we can calculate, 7 pi over 4 plus 2 pi times 1 over 3 is 5 pi over 4. As is here. And do the same thing with our last one, except instead of having 1, we will have 2, 23 pi over 12. And these 3 here are our 3 roots. Now the last thing we can do is just plug these in and see what we get. 6 root of 2, cosine of 7 pi over 12. Negative 0.2905. I'll say the 6 root of 2 sine 7 pi over 12. 1.0842. And then we'll move on to 5 pi over 4. Negative 0.7937. Sixth root of 2 sine 5 pi over 4. Negative 0.7937. And lastly, 23 pi over 12. .0842. Calculator. And I mean, if we wanted to, we could have come up here, selected this, cursor back over, and say replace cosine with sine, negative 0.2905. But those are our final answers. Questions on this here? I mean, that's it. And that's the end of our last chapter.